Welcome.
To the joy of coding.
Hello, and welcome to episode 85 of The Joy of Coding. My name's Mike Conley. We're going to be hacking on Firefox stuff today. It's 2017, first episode of the new year. How are you doing? It's been, I think, 2 weeks. We skipped a week because of the holidays, and now I'm back, and it's 2017, and I hope you had a good holiday if you took one. I sure did, although I got a little bit sick. You can probably hear that in my throat. I'm a little stuffed up, a little congested. So we'll see if I can stick it out for the full hour and a half. I hope I can. I've got, I've got my system loaded with like tea and coffee, and I'm fully caffeinated. So hopefully we can get ourselves through the hour and a half. What are we doing today? Well, let me share my screen with you. Whoop. Whoopsie daisy, that's not what I wanted to show you. I want to show you the agenda. Today is January 4th, 2017. No plan survives breakfast. This agenda is kind of how I imagine things are going to go today, but it might not be. Things might go horribly wrong. I might get distracted. I might go off track. That's okay. That's kind of how these things go. Just bear with me when we'll see how far we can get through these things. I might not get to them all. I might only stick with the first one. That's very likely, or who knows. I might not go in order. This is just something I draw from whenever I need stuff to do. So that's the first thing, is no plan survives breakfast. And the second thing is this agenda is actually something that you have access to if you don't know this. If you're watching this right now live on Air Mozilla, if you scroll down, there's an additional links section. And in that additional links section, I put a link to this agenda. And you can go check it out, and you can click on links and follow along. And as I update it, it will synchronize. That little blue spinny will happen. And then I think you have to reload the page. And then the changes I've made will be manifest to you. Manifested for you. So you can go check that out. So just want to make sure everything's working. Yes, you can hear me. Yes, I've got sounds working. And yeah, I'm not dropping too many frames. We're recording. Okay, that's good. Second thing is, we're roughly at 2 years of the joy of coding. Holy smokes. So that's 85 episodes. That's not exactly, there are 52 weeks in a year. That's definitely below 104 episodes because I skip weeks periodically. There's like vacations and some things have been skipped. And there were a couple of episodes at the very beginning where I don't think I started counting properly. I think I was just like doing pilot episodes or something. But I have been live streaming for about 2 years now. And so we did it, 2 years in, and let's hope for 2 more years. Let's hope for 10 more years. Let's see how long we can keep doing this. So enough jabbering on and on and on. We've been at this for a couple of minutes now. Let's just get to coding. So what are we doing today? Great question. Today, I'm hoping to write some Rust. Rust, if you're not familiar with Rust, is a programming language that Mozilla sponsors the development of. I think we fund the development of. It's a new systems programming language that, here's the sales pitch, systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. It's actually quite nice. I've not used it. I've never written any Rust before, except for like a couple of the sort of exercises, the Hello World exercises, some of these sorts of things that you can actually run on the web and the sandbox, because I've never had occasion to until today. I've actually got an excuse to write some Rust today, so that's what we're going to be doing. But I should preface that by saying that Rust is quite new to me. I mean, despite the fact that I've read some of the Rust book, like there's this Rust documentation that's quite good. I think I've read sections of the Rust programming language book. There's something Rust by example. I've gone through a bunch of this, and I've read through all the different structures. I have a sense of how to read it, but I've never kind of like a language, like a written language or a spoken language where I've gotten good at reading it, but I'm not very good at writing it yet, or I haven't had a lot of practice writing it. And that's not unusual if all you've been doing is studying, but not actually like trying to compose, like synthesize stuff with the language yet, at least in my experience. So today we're going to be doing that. We're going to start simple. What are we working on? That's a great question. So how do I explain this? So there's not a whole lot of Gecko that's written in Rust yet. There are certain things that are. I'm not going to be working on anything that's currently in Gecko in the tree. I'm actually working on something that we're hoping to land in the tree soon. You may have seen me in the past work on these files, or like modify these files that end in .ipdl. Let me find you an example of one. Like whenever we were doing the printing stuff way back in the day, printing, pprint. There are these files like pprint progress dialog.ipdl, and what this is, it's a interface, like interprocess definition language. I think is what it stands for. I might not have that right, but the idea is correct. Where what we're doing is we're defining a protocol for communicating between the content and the parent process, or between processes, I should say. We're defining a protocol, and so this is like a language. It's kind of like a DSL for defining a language, or that's not right. This is a DSL, a domain-specific language for defining a protocol for speaking between the two processes. So like you write this sort of like in this language you define this protocol, and then we run this tool that goes through all these IPDL files, like this one, because this is an IPDL file, and it turns this stuff into C++ and C headers. It like generates a bunch of C++ and C headers for us, and gets rid of a bunch of boilerplate for interprocess communication, and then we like inherit from the things that that C++ creates, and like actually instantiate the not instantiate, flesh out the methods that are defined inside this IPDL file. So for example, we have this language that's saying, okay, well, we're creating this protocol called pprint progress dialog. It manages a subprotocol called pprinting, and then the parent process might receive these async messages: state change, progress change, doc title change, and then the child might receive this message, async message called dialog open. And then pprint progress dialog, when the IPDL parser is what we call it, goes through, it will generate the C++, and that will create something called p progress dialog. Like this is some of the generated code is right here in SearchFox. So pprint progress dialog will be generated, and then pprint progress dialog child and pprint progress dialog parent should also be pprint progress dialog parent should also be, yeah, generated right here. So this is an example of one of the generated files. It's like a bunch of boilerplate to do the actual IPC communication between the two processes. So this is all kind of scenery, but what you need to know is that we get this file. We have these IPDL files, and there are a bunch of them in the tree. Like here, let me actually show you a bunch of IPDL files. So here's a bunch of IPDL files. There are a bunch of them in the tree. There's a whole lot. Those go through some Python, and out the other end comes C++, source files, generated C++ and header files, and then from that we like can compile them, and it does the boilerplate. And that Python file is called, strangely, I think it's pdl.py. Hang on, I've got this IPDL filter on lowered. It's strange because it's called lower.py, or part of it is called lower. And this is a big, giant mess of a Python file. It was kind of written in a hurry, I think. It was, and it's kind of hard to deal with. It's hard to reason about. And what this is doing is it's like parsing the IPDL files, and it's creating this sort of abstract syntax tree thing. And then from that, it generates C++. Like, where's an example of some C++ being generated? Like cxx cgen.py, I think. So here we'll write, like this is an example of us writing some C++ here. Like we're writing these macros and static and virtual. Like it's this weird kind of metaprogramming where this program is writing a program, and this program that writes the program is written in Python. It's a bunch of Python modules, and they're kind of hard to reason about. And one of the other things about them is that it's a little slow. Running all of this Python, I think we can only do it. I think we do it single-threaded. It's a little slow, and it'd be nice if we could rewrite this in Rust. And I think that's basically what's going on here. So Andrew McCrate, a great developer here at Mozilla, opened a bug to rewrite the IPDL parser in Rust, and I'm going to try and find the source bug for that. Here it is, RIPDL. I'm not sure if that's like a rest in peace pun there. I'm not sure, but it's probably R for Rust. This is the bug that you should check out for some arguments. I'm going to update the agenda with that. And so one of the other advantages of rewriting it in Rust is that SearchFox, which is the tool that a bunch of us use to search through the codebase, will be able to do some really interesting things for like reasoning about the source code. Nicholas Nethercoat says, what's the benefit of doing rewriting it in Rust? Bill says the IPDL compiler is surprisingly so. It adds about 1 minute to Windows builds and needs to run before anything is compiled since a bunch of stuff depends on IPDL generated headers. Bill says lower.py is some of the worst code that we have. 5,000 lines of dynamically typed crap in a single file. It's really hard to change because it involves constructing an AST that's never fully defined anywhere. You kind of figured it out each time you have to hit an exception. My hope is that Rust will make this a lot better. It has a lot of similarities to ML, so I would expect it to work pretty well for writing a compiler, if nothing else. Having a type definition for the AST, both for IPDL and for the C++ we generate, will be great. So there is a project. So just assume that an argument, sort of a discussion, a discussion took place in this bug about whether or not we should rewrite the IPDL parser in Rust, and that the conclusion was, okay, let's do it. And so there's this project on GitHub, which I will now link to. Oh, I already have more or less inside the agenda. This is the IPDL parser written in Rust. It's started by Andrew McCrate on GitHub. He's got a good start on this, and what we're going to do today is I'm going to sort of tour you through the code, talk you through it, because I myself need to talk through it. Then we're going to write a quick patch for it to add some logging, because I filed an issue. I want to get started. I want to write my first Rust code, and one of the things I noticed is that whenever Andrew McCrate first started to use or started to write this stuff, he was doing print lines for errors, print lines for information. And that's fine, but it'd be nice if we could like use one of the built-in logging crates. That'd be great. And I noticed that there's been a little bit of traffic in here as well. So on January 2nd, add location tracking in lib.rs. So it looks like there was a little bit of traffic in here. We're going to be looking at interesting. We're going to be looking at a basically the IPDL parser. I'm not fully familiar with it yet, but we're going to look at it right now. We're going to try and read it and understand it, and then later today, or hopefully within the next 30 minutes or so, we'll start writing a patch that's going to cause us to use a logging module instead of print line. It's very, very simple. We're just going to replace a bunch of places in the code with with a logging module instead of print line, and then we'll open a pull request and see if Andrew McCrate likes it, and we'll accept it. And that will be our first very simple patch. I find that that's like a nice way of getting my toes wet in a project and not like taking too big of a chunk, is to like find some small task. Even whenever, I'm a software developer that I've been working professionally for 5 years or so. Whenever I'm new to a project, I like to get my toes wet very slowly. I like to sort of ease myself in to sort of get a sense of the workflow, and so I'm going to try and find something very small to do right off the bat instead of like trying to bite off too big a chunk and getting overwhelmed. But we're getting ahead of ourselves. Let's explore this source code and figure out what's going on. Now, I've actually cloned the source. I've got my own fork of, pardon my sniffles. Pardon my sniffles, I'm still recovering from a cold. The first thing I'm going to do is I'm going to actually update my fork with the most up-to-date stuff from Andrew McCrate's repository. So let me bump up the font here and then drag this up so you can make sure you can always see it. So I'm going to cd into my fork that I've cloned, and now I've got a remote for McCrate and my own fork origin. I'm going to fetch from McCrate. I'm not super comfortable with Git. I used to be, but I've gotten more used to Mercurial back in the day. So I might be a little bit slower with this than I used to be. And I'm on logging. All right, I'm going to check out. Do I have any differences? I'm actually going to reset all of that stuff because I'm going to use it. We're going to rewrite it. We're going to do it ourselves later. I'm actually going to start from scratch. I'd started to do it, I think, on yesterday, but I decided I'd make it part of the joy of coding. So I'm going to actually start from scratch, delete that logging branch. There's some stuff in there that we're going to fix, but we'll do it. We will do it on our own in this live stream instead of basing it off of work that you haven't seen yet. Okay, so I'm going to check out the create master. I'm going to pull and fast forward us. So we should be at the most up to date, which was January 3rd, yes, and now I'm going to merge that into my own master. Merge create master, and that should be a fast forward. Yeah, that is a fast forward. So the top commit should be B6C. Yeah, it is. Okay, great. So now I'm going to push that to my own master. So now my fork should be up to date with McCrate's master. So if I reload this, I should have all that good stuff. Good. I've got build stuff. That's great. So now my source is up to date. Let's start exploring this thing. So like I said, I'm new to Rust, and oh yeah, sorry, I should make a reference to my beard, Madeline. Madeline, hello. Thank you for calling out my beard. Yes, I have a beard. It is new. Thank you for noticing. If you watched the previous episode, you can see it starting to emerge. And then I cut my hair and I got a beard. So I'm not sure how long this is going to stick. We're going to try and see what my face can do over time. Okay, so what's inside this file? Or what's inside this repository? We've got this file called cargo.log, cargo.toml, build.rs source, and target. Okay, so what are all of these things? Well, I know that Rust ships with like a package, or has its sort of package management ecosystem, and there's this thing called cargo. So if you've ever used Python, there's something called Python packages like PyPy, the Python package universe, and if you've ever used apt on Ubuntu or any Debian Debian-based distro, there's like this package system, and you can download packages and compile them and whatnot. So cargo is the Rust version of that. And it's really nice because a lot of systems languages don't have a kind of like package universe, like library module jargon ecosystem like this, and with cargo we do. So cargo is this tool that ships with Rust, and I can do all these things with it. I can like start a new project, I can run tests on things, I can kick off builds with it. It's really nice. And so cargo.lock is, I believe, a file that well, let's look it up. I'm pretty sure it's supposed to like make sure that we're using the correct versions of things. What is cargo.lock? Let's look it up. Cargo guide. Cargo.lock. So there's this cargo.io, crates.io page. Crates and cargo. It's like this shipping container metaphor. And crates.io is where you want to go to get a lot of information here. I'm actually going to put this in the agenda. So you use cargo to get a crate. A crate is like a Rust module. And I guess this documentation is going to tell us about cargo.lock. Cargo.lock contains information about our dependencies, but we don't have any yet. So cargo.lock contains information about our dependencies. And if I look inside it, it's actually, I'll open it up inside Sublime. There's like information about all the stuff we need in order to compile it, and I guess it's like the dependency tree that is constructed from all of the things that are required by the Ipdl parser is used to like sort of make sure that all of the versions are more or less locked down, so we have a snapshot of all the different dependencies and that they're not like fuzzy dependencies like some version of Lallerpop, for example. It's this version, 0.12.1. I'm guessing that's what it's for. And I don't think we're supposed to ever write to this file. Cargo.lock is something that's generated. Cargo.toml, TOML I think is like some kind of markup language. TOML markup, what is it? It's called Tom's Obvious Minimal Language. So it's a language for, it's if you've ever used YAML or I don't know, JSON. It's something. It's kind of like that. It's this like sort of easier to parse or easy to read thing. That's all like it's a file that is both machine and human readable, and that's always kind of the balance. It looks a lot like what you'd find inside like one of those old school .ini files. But here it is. So inside cargo.toml, we have all of these things where we declare like what the name of the package we're working on is, who the author is, and then we have this. We can say that if we're going to build, we have this build.rs file, I guess, and then we get to talk about our dependencies. Lallerpop. Lallerpop, if you're not familiar with it, I'm barely familiar with it. We're going to get more familiar with it as we do this. Lallerpop is a parser like library for Rust. Parser generator. So we're parsing Ipdl files. Lallerpop is a tool that allows us to like create a grammar. If you've ever used Lex or Yak, those like super old like Unix tools for creating parsers, this is a way you can like, this is a library for creating a grammar and turning it into like a data structure that you can like reason about, maybe even like turn into bits for a binary or something. Like this is a Lallerpop is a library you can use for creating a language pretty much. And there's like a lot of documentation here. I don't really know. I know a little bit about Lallerpop, and as we go on, we'll hope, I guess, learn more and more. But we need it. Ipdl parser needs it. Jote says, I've seen Toml in Golang code a lot. Wow, you're talking about Rust. Nice. Yes, I am talking about Rust, but I am such a noob with Rust. There are other people who know a lot more, so don't expect. So the stuff that comes out of my mouth, take it with a grain of salt with Rust. I'm starting like quite a bit from scratch here. I'm just scratching the surface of it in my head. So if you're new to Rust, you're just like me. I don't really know what's happening. I can kind of read it though, so maybe we'll read some together. So we require Lallerpop to build. We require getOps as well. Like when we build, this is interesting. I don't understand the difference between build dependencies and dependencies. We should probably understand that. Because like, I guess we're gonna statically build with Lallerpop, but maybe if someone install. It's weird. I would expect we would do the same thing with getOps. getOps is what's used to like parse our options, like command line flags. It's a library for doing that, I'm pretty sure. That's usually what getOps is. And I believe that's what's being used for inside. Yeah, for adding command line flags. Yep. Simple get opt alternative. So let's quickly understand what's the difference between dependencies and build dependencies. I want to understand that before we start doing stuff. So creates specifying dependencies. You can depend on other cargo-based crates for use in your build scripts. Dependencies are declared through the build script. Oh, I see. So build is our build script. This is what's going to run in order to build this crate. And this crate is Ipdl Parser, because we're creating a crate. And when we're building, we, I guess, need to have access to Lallerpop. And that's true, because when we look inside the build script, it requires a Lallerpop in order to, like, I guess, do the work of constructing the, taking our... there's so many like it's very like meta, because Lallerpop is going to take a grammar that we define and turn it into Rust code, and that grammar that we define that turns into Rust code, that Rust code is going to be used to turn IPDL into C++ code. You see, like it's a little weird. We're using a library to create a grammar to create a library that's going to create and parse a language. In this case, IPDL. It's a bit weird. This unwrap process root unwrap thing, this comes straight out of the Lallerpop documentation. You have to do that. You have to use this build.rs file, and that's what's going to be used to create all of the generated Rust code for the grammar that we define. Okay, and that's why that's needed in build dependencies. And our general dependencies are Lallerpop util and getOpts. That's interesting. I'm surprised that it doesn't need. Well, I guess you know what? If we've Yeah, okay, that makes sense. That makes sense why we wouldn't need Lallerpop under dependencies, because Lallerpop is going. I hope I'm pronouncing that right. Lallerpop is going to generate a bunch of code for us, and once it's done that, its job is done, and then we can just compile that generated code. And maybe there are some utilities that we need for Lallerpop, and that's why we need those at like compile time. Okay, that makes sense to me. So these are going to be statically linked in, I believe, to the final binary, but this one is needed at build time. Okay. Like, not just build time. This one's needed in the build script itself. Okay, I understand. I understand. Okay, moving right along. What else do we have in... where am I? What else do we have in here? What I should do is I'm going to add this folder. I'm going to add this folder to my project here. Okay, so we also have a gitignore file. We're going to ignore ipdl.rs. I don't know why we're going to ignore that, but we're ignoring target and anything with the tilde symbol, I guess. I think that's what that means. We're going to ignore everything under target. I guess target is what's going to be generated. Maybe this is like all our build artifacts or something goes under target. But source seems to be where all of the interesting stuff is. And for some reason, ipdl.rs is being ignored. Oh, you know what? I'll bet ipdl.rs is the generated code. Yes, it is. Okay, that's what's going on. So, here, I don't know if you can read this. Maybe I'll bring it up inside. So this is the list of stuff inside the source directory. We have ast.rs. We got all this stuff, all these Rust files, and that's great. And there's a main.rs. We're going to be looking at that next. But the one thing I want to point out is there's this file called ipdl.lallerpop. And this is the stuff that the Lallerpop library, when the build script runs, is going to look for. It's going to find it, and it's going to generate this, ipdl.rs. That's the generated Rust code that's going to be used to parse the IPDL, I guess. And so like this is a bunch of generated Rust. It's like kind of hard to read, but that's okay. It's a lot of boilerplate machine-generated code. Machines tend to not write very beautiful code, I guess. It's very boring code, I guess, monotonous, and that's why we have machines do it. But the Lallerpop grammar itself, this is what's defined in this is the .lallerpop file I'm looking at right now. This is where we can use sort of a more human-readable language to declare and define the IPDL language that we're going to be parsing. Don't get lost in all of this like meta programming stuff. I want to really make sure that you understand this. I want to make sure I understand this. Lallerpop is used to take some grammar and produce a parser for a grammar, where this IPDL Lallerpop is creating a ipdl.rs file, which is a grammar parser for the IPDL language. Okay, so now we have a parser for the IPDL language. That parser is going to be used to parse IPDL files and produce C++. So in a way, we have a parser generator, and then we're going to parse IPDL and construct C++. It's very convoluted, but that's the story. So yeah, this Lallerpop file is very interesting, but it's also not the part that I'm going to be working on, I think. The IPDL language itself is, when I was talking to McCrate about this, the part that I'm likely going to be focusing on is the generation part, the part where we generate the C++. And so he and I think Bill McCloskey are going to work on specifying and properly defining the grammar for IPDL in this Lollipop file, and I will work on generating the appropriate C++, is the goal, anyways. So, where do I want to look at next? I'm going to look, generally when I look at a project I'm not too familiar with, I'll go for the main. I'll try and find the main entry point. What's the machine going to run first? Usually there's a main function, and I found it. It's inside main.rs, and there's this file called main. And it would be really great if Sublime knew how to syntax highlight Rust. I'm going to see if I can add some syntax highlighting here. Sublime highlight Rust. There should be a way of just... I need it for Sublime 2. Sublime... Sublime Text. I'm a newbie. How do I do it? A thing for Sublime. This is the official Sublime Text 3 package. This no longer will support Sublime Text 2. Boo! So it wants us to use Sublime 3. I have a copy of Sublime 3. I wasn't expecting to use it, but okay. If we need that for oh shoot, if we need that for Rust syntax highlighting, then okay. Let's see if we can get it. Ipdl Parser source main.rs, bump up the font, and then let's see if we can tools. Let's add a new. How do we install this for? Install the package control package. Oh, I don't have to do this. Yeah, I don't want to have to do this. I'm going to use, I guess, Vim. Maybe Vim will be able to read Rust a little bit better. Yeah, that's what I'm going to do. It's a little bit better in here. It's not too much better, but it's a little bit better. Okay, so we're going to look inside this main file. What do we got? Okay, the first thing we do inside the main function is we are getting the args that were passed to this command. So what we're going to be generating is like something called ipdl_parser as a binary file that you will execute, and you can pass flags to. And the first thing that we're going to do is we're going to create a vector of strings, so a collection of strings that that were passed to the command line binary, I guess. So we've got our arguments here, and then we have this thing called let opts equals get options parser. Get options parser is defined up here, and what it's going to do is it's going to return a thing called options. Options is something that get opts gives us, so it's some kind of structure, I guess. And we're going to create, so this is us saying define a mutable thing called ops, that it's one of these options thingies, and I'm going to, I guess this is how we're going to define what kind of options can be passed to our command line, our ipdl parser executable here. Ops.optMulti, I guess there's a dash I, or we could do dash dash include. I think that's how this works. So if we have a single character, that's a single character flag, or you can do like a whole word dash dash flag, and that's the alias. And then here's the help string, which is additional directory to search for included protocol specifications. And I think this dir is, I don't know what this is for. I don't know what the third argument for opt_multi is. Let's take a look. Rust get opts. Oh, and let's take a look at opts multi. The third argument is the long name or self opts. Impl options. Oh, I see. So we have the short name, that's I, the long name, that's include, the description here, and then the hint. What is hint? Hint that is used in place of the argument in the usage help. Example. Oh, okay. So this will be placed inside the help as like what this will be. And in this case, you want to include directory, so it's dir, all caps. Okay, and we have one here for directories into which C++ headers will be generated, and we have an option. So I guess this is opt multi because you can include multiple directories or, to search for included protocol specifications. But this one, opt d, opt d is just a single argument that's where we're going to output the final headers, and this is where this one opt o. This is where we're going to put our final C++ source. So the C++ files and the header files will be can potentially be in different directories, and then we can search for Ipdl files in here, and then we return this opts structure that we created. Okay, so that's what we get from here. We have this opt structure now, and then we do something called matching, where match to me is similar to like switch, a switch statement, but it's got, I think it's like switch but with more power, where match is used to say, okay, run this thing ops.parse, and I guess we're passing it all except we're passing a reference. That's what that ampersand means, to the args that we got, this args vector from 1 to the end. This is kind of like Pythonic, but what this means is like take of this vector, go past the 0th item, take the first item, and then dot dot means like to the end, and I'm pretty sure that means inclusive, so including the last item, and then run parse on it, like past that to the ops.parse, and that ops thing is what we got back from get options parser. So we're gonna parse the arguments that got passed in, and then we are gonna have one of two things come back from ops.parse. We're gonna have something called like we're either gonna have OK or error, and this is a thing that like we're gonna have to get used to, and this is where there's a little bit of an overload in the names. So we have this thing called get options, like get options parser, and that we've returned a thing called an options. But within Rust itself, there is something completely separate called an option. And we need to keep those separate in our heads, because in Rust, option means something completely different from what get opt and get opts provides. So option in Rust is actually quite interesting. I think in some languages they might be called monads. I think they're called monads. Yeah, so this is a thing. If you want to be able to return either an error or maybe some result from a thing, I mean, back in C++, what we normally do in Gecko code is we'll have a function that we'll have it return some return value, a status code like success or failure or particular status code, and if it returns success, then we'll have some out params. We'll pass some out params where the function can write in, like, modify some stuff and return us a value through some structure that we pass to it. And then we look at the status code of the function. If it's like success, then we know that, or the convention is then the function that we called probably wrote into the structure that we passed to it. That's not amazing. It'd be nice if we could have like a thing come back from a function and be able to reason about whether or not the thing that came back was an error or it's the stuff that we want, like it was a result. And that's kind of what an option is. And so an option can be, let's see here, some or none, I think. Or can also be error. Rust option error. What is this? Error handling. Option. Okay. Error. I need to find oh, maybe it's result. It's not it's not an option that we're dealing with. It's something called a result. A result. A Rust result. Okay. A type used for returning and propagating errors. It's an enum with the variance OK representing success and containing a value, an error representing error and containing an error value. So the thing that we get back might be an error or might be a result. And so this is an example of us calling a thing. Like suppose we have this function. Oh, I see. So here's an example where we're like parsing a version. We create a function that takes some collection of unsigned 8-bit integers and will return a result, which is a collection of a version, and like a result takes whenever you construct it, when you define a result, it's gonna, the first argument is like the success, the result, and the second one is like what the error, if there's an error return, what it's going to be. In this case, it's going to be a string. So in the success case, we'll return a version. In the error case, we'll return a string. And then in this function, we look at the first item, I guess, of the header and see if there's nothing there, then we return an error. If it points to, I guess, the reference to 1, I guess they'll point to the same thing, then okay, it's version 1. Points to the same reference to 2, then we'll point to version 2. Otherwise, if it's some other thing, then we'll say an invalid version. So I guess we only care about the max value here, the highest value, the major version number. And if it's 1 or 2, then it's okay. Otherwise, we return an invalid version. And then what this thing does is it's going to match the result of parse version 1, 2, 3, 4. And if it's okay, and okay means that we return some result, in this case okay version 1 or okay version 2, then we can run the function in here with that result. It'll be defined, assigned, the result will be assigned to v. Otherwise, in an error case, we will have an error string assigned to e, and then we can print that out here. Okay, that was a long and winding explanation of what's going on here, but basically, whenever we run ops.parse, if it parsed correctly, then we will have something called m, which I believe we then assign to matches. That's what's happening here. Rust is really beautifully expressive here. What this is saying is whatever the result is for these two things, assigned to matches, although in the error case we're going to panic, and panic will just cause us to like exit. I'm pretty sure exit with an error code, and we'll exit with 1, I think, and it's going to print. Panic, I think, takes a string. It's going to take the error string that was passed back from the options parser and just print it out. Otherwise, we will assign the parsed matches to matches. Okay. So that's what happens there, and then we're looking to see if matches.free is empty. Now, matches.free is, I think, after all of the flags that you can set inside, like that you can pass to Ipdl parser, then you can like pass any number of, I think, just files or directories, any number, and I think that's the free collection of arguments or options. And if it's empty, then we will panic with this string and we'll exit. Otherwise, we know we have at least one. It may or may not be valid, but we have at least one free string that's hopefully either a directory or a path, direct path to an Ipdl file. Then we create a vector of include directories, a mutable vector. And then for each of the matches that is assigned to I, that's the include directories that we defined up here in opt multi, I guess, we're going to push those directories, those path buff. What is path buff? I'm guessing it's some kind of like data structure for file path on the file system. What's it from? performs the conversion, takes a string, and then will return a path buff. And a path buff is something that can reason about the platform's file system, I guess. So we're taking a string and we're going to convert it into a path buff, and we push that into our vector here of include_dirs. And then we do the same thing for all of the free matches. Presumably those are all file names, I guess, because looking at that here, we're going to create a new vector. We're going to do the same thing. We can push those onto the file names vector. And then we have this thing called maybe twos. We're actually going to run the parser, the Ipdl parser that we've created with Lollipop. We're running it on both the include_dirs and the file names. Now this parser thing is not defined in this file. It's actually up here. And there's a separate file called parser, and we're going to enter that in just a sec. But once that's all done, I'm guessing TUS is some kind of like final data structure that comes out that we can use to like generate the C++. But if it's none, then parsing probably failed, and then we're going to print this error message: specification could not be parsed, and then we'll return. Otherwise, we take the data structure, we unwrap it. So I think unwrap, you'll often see that a lot in Rust code. That's basically us taking an option, a thing that might be like an error or a thing or its error. We take it, and assuming it's not an error, we get the actual thing that's inside it. We unwrap it. I think that's how it works. I'm not really explaining that correctly, but under rust.unwrap, it will take an option, and unwrap will give us the underlying value. The sum value underneath it. Although, because this function may panic, its use is discouraged. Instead, prefer to use pattern matching and handle the none case explicitly. So we could potentially rewrite this to use pattern matching. In fact, that would be a nice little patch right there. We could use pattern matching instead, and I think Rust people would be happy with that. But regardless, we unwrap and we get the resulting abstract data tree, I guess, and then we try and print it out. Presumably it's a thing that can be printed. And right now the parser is just printing it all out. And then for each of them we're doing a type check on them. I'm not sure what type check is, but I'm guessing it's some post-processing that's also defined inside this file. And that's it. That's all this file does. That's what main.rs does. So that's that. So the thing I'm more interested in now is parser.rs. This is the thing. Oh, actually, let me open up main.rs again. So parser.rs is actually called from this line here, where we're getting the maybe TUS. I don't know what TUS stands for, but that's what the parser might be returning, is some TUS's, and it's calling parser parse. So there must be something called parse in here. I'm looking for it. So there's this public function in this file called parse, and it is taking an include directories vector of path buffs and file names path buffs, and it's going to return an option of hash map. So it might be a hash map. Oh, translation unit. That's probably what TU stands for, is translation unit. And translation unit. What's a translation unit? Looks like something that is defined, I think, by Lollipop. Yeah, because AST is something that Lollipop gives us. So a translation, I think it is AST translation unit. Oh. No, so this is a thing that we've defined ourselves inside ast.rs. I guess this is what we've ended up calling this thing. That's what is going to be generated by our parser, and it has all of these things on it. A translation unit might have a namespace, a file type, a file name, the includes for C++, other includes, something called using, structs and unions, and then the protocol. I don't know what that means. But I'm guessing a translation unit might be the top, like considering the arguments that are being passed in here, there'll be one translation unit per Ipdl file. Because it looks like there's a file name, and then it has like the structs and unions, and then the protocol, which has namespace and protocol. And protocol is something that's defined in here, like protocol pubstruct. Yeah, and protocol will have like managers, manages, and messages, and then inside messages there'll be like there's probably a public structure of a messages, and message has an identifier, it has priority. So like these structures are what's going to come out after we've parsed. And at the topmost level, each Ipdl file, I guess, will end up creating us a translation unit. And so when we parse, we'll hopefully end up with excuse me, a hash map of file names to translation units. Okay. That makes sense with our mental model here. And so the first thing we do is we create this mutable hash map called worklist. That hash map key has the key of a path buff, and the value is some vector of path buffs. And then we create a new parsed hash map. And then for each file name that we were passed, we're going to try to resolve it to a path. Resolve include path. What's that? We're going to look inside each of the include directories for a particular file and see if it exists, I think. So for each include directory, we'll clone the include directory, and then we'll push file path onto it, which I think appends the file path onto the end of it. Excuse me. And if OK equals p.canonicalize, so if a path buff can be canonicalized, let's see what that means. Rust path buff. I believe canonicalize means like is a file. It's a kind of a weird name. Returns a canonical form of the path with all intermediate components normalized and symbolic links resolved. Canonical form. This is an alias to fs canonicalize. Function will return error in the following situation if the path does not exist or a component of the path is not a directory. So this is us making sure it exists. Okay. If so, then we return the path buffer, the canonicalized path. Okay. Okay, I get it. So we're resolving, and in the event that we cannot resolve it, I guess we get a none back, and then we'll say, hey, we couldn't locate a file, and there's a typo in here. I'm going to exit out of Rust main.rs now, but there's a typo. Maybe we can fix in a commit. Command is spelled wrong. We could probably use logging instead of print line here, and we return none. So what we'll end up doing is for the ones that we can't locate, we end up returning none, and I think that ends up being assigned to FC. And then FC is where we're going to worklist is we're going to assign FC to, we're going to insert that into our hash map. Which is weird because none is not a path buff, I don't think. That's kind of weird where we could like potentially assign, like we should probably not insert FC if FC is none. Is my preference. Okay. But anyways, for the ones it does find, it inserts it into worklist. And then it's going to loop through the worklist. So basically, it's gone through all the file names that we were passed and went through all of the included directories and then did a bunch of matching to try and resolve them all to actual files. And so what we end up with, or what we should end up with, is a hash map where the keys are all these like file paths that exist. And the values are just these empty vectors. And then what we're going to do, while the list is not empty, we're going to create a new hash map, and then we're going to go through each item in the work list, and then we're going to attempt to parse the file, and then TU is the translation unit that we'll get back. If we get a translation unit back, then we assign that to TU here. Otherwise, we will print the include context, we'll print some kind of error, I guess, and we'll return none, and TU will be assigned, TU will have none assigned to it. And then for I in TU.includes, which will be strange, like if TU is none, I don't know if this is going to work. But for each I in the include, so assuming this worked correctly, we have some translation unit and there's an include, then we're going to look through each of the includes. We're going to do the work of resolving the path for that, for the include as well. Okay, so we passed in a bunch of file names, a bunch of directories, and those files that we resolve to might include other things, so we're doing more work to find more stuff that may not have been passed initially. So we have to resolve those as well. And then we check to see if we have already parsed it before. And if so, we bail out. Otherwise, we will create a new context. Take the include context. What is the include context again? Some include context here is some vector that that's the value for the hash map that we had worked with before. We clone it and we push it into new context, and then push context, and then new work list, we insert, we overwrite, I think, because new work list is a hash map. We'll overwrite P if it exists, or if it, oh, it shouldn't exist, because if it did, we would have just continued here. But we'll insert a new item P with the new context, which is a copy of the current context, along with the current file cloned. Okay, I assume that's correct. And then we will insert that cur file. Cur file is what we will end up with. We'll, hopefully at this point we'll have some translation unit, and then we'll clone the current file, and we're going to insert it into our parse list, so the work is done. And then if we have a new work list, we'll assign it to work list. And in the end, we're going to just return whatever was parsed, whatever ended up getting added to this list. Okay, so that's pretty straightforward, I guess. So there was a function called in here called Parse File that I want to look at next. That was called right here. And so let's look at that next. Parse File is going to take some path buffer with a vector of include directories, and then some file name that is some path. That's interesting. It's not a path buffer, it's a path. Cur file. I guess when you canonicalize something, it becomes a path. Is that true? Canonicalize should return a path buffer. But then you can get it as path. So coerces. I wonder if we're doing some coercion here. Parse file. How are we doing that? Cur file is in work list. Work list is keyed on FC, and that's what cur file will be. It will be a type of FC, and resolve include path is what's going to return some PB. PB is PB is also passed a path for file path. What? Where's PB? Okay, PB. Oh, I guess PB is what's. Okay. What? That should probably be P and not PB, right? Unless p.canonicalize. This is maybe p.canonicalize returns a path buffer, and then we're saying if that's equal to OK some path buffer. That's weird. Because what is PB? That's very strange how it would do that. Kind of weirds me out a little. Whew, it is boiling in here. But file path. Oh, file path is P. D is include dirs. We clone it and then we push a path. So I wonder if we're just somehow coercing a path buff to a path. Also implements deref to path, meaning that all methods on path slices are available on path buffs. Struct standard path. So I wonder if, yeah, it just implements all of the path stuff. And in that case, it's just polymorphism, something or other. Anyway, so we're going to parse this file. So we get the file type from the file name, and we're going to open the file. We're going to create some new string, mutable string. We're going to read the file into the text string called text. And we're going to run something called uncomment, which I believe I've seen there's this other file in here called uncommenter, which is just going to strip all the comments out. It does just like some state machine that looks for comment structures and just strips them out. So I'm not going to go into that too much because we're burning through time. I like to write some code, but it removes the comments, and then we create a vector of byte offsets of all the new lines the input will use to resolve line number, call number pairs. So we're gonna new line offsets, let mut offset equals 0 for each line. We're going to create these offsets, and then we use parser state, parse translation unit, and I think this is a thing that's being generated by Lawler-Pop, and we pass in the parser state, and then in the end we're going to get either a couple of errors here. There are all these types of errors that we might get, but otherwise I think we return the return value of parse translation unit, which I guess would be a translation unit. We're going to get a translation unit back, and we just return it. Okay. So I think I understand all that. So let's write some code now. Well, first of all, let's try build this. Let's try to build it. Cargo allows us to build with using something called cargo build. So it's going to attempt to build cargo or Ipdl parser. So we're building. Hey, we finished in 10 seconds. It took us 10 seconds to build, unoptimized with debug info. Okay, so let's start making some changes. Oh, sorry, you probably can't see what I'm writing down there. With Git, I like to create a project branch, so I'm going to check out a branch. The first thing I'm going to do, we're gonna try and sub in some a logging mechanism that is not printline. So that's my suggestion for logging. So I'm going to do that here. Checkout B. So I'm going to call it logging. So I've checked out a new branch called logging based off of my master. And the first thing I'm going to do, I've already kind of done a little bit of research here. There's this thing in Rust called envlogger, which looks useful. We don't need like super complicated logging semantics or features, just a thing that will read some environment variables and be able to determine how much we should be logging. So envlogger is here. Here's some documentation where you can just like import it, you initialize it, and then you can set an environment variable to let you know what kind of logging you want. And then you can also like format that logging. So let's try and add some logging to the file, or to our structure, to our project here. Sorry, I'm still my brain is slow. I'm still getting used to live coding again, and I'm still a little bit sick. So we're gonna add. I believe there's a dependency on log here, and so we have this crate called nvlogger. So I'm gonna say nvlogger, and what's the most recent version of it? 0.3.5. So I'm gonna drop that into my cargo.toml, and then there's a log one as well. Now, I wonder if I don't need to do that because log is a dependency of nvlogger, and so it'll probably just get it itself. So if I do like cargo build, what's it going to think of this? So it's updating a registry, it's compiling Ipdl parser. So it's building it, and then like if I look inside the cargo.lock file, is there anything in here about log? So it got nvlogger, and then yeah, it got itself a copy of log and regex, which were the dependencies. Okay, so that's good. So now inside main.rs, we can start importing it and using it, I think. Actually, let's go back to the documentation for nvlogger. How do you use it? So macro use extern crate log. I think we need, I want to know what this means for Rust. Macro use. Macro use attribute can also appear on an extern crate. In this context, controls which macros are loaded from an external crate. So there are macros that are available to us, and I think debug, error, and info are those macros. And so log gives us those, and if we put in this line, it becomes available to us. So let's just add these two. Log and vlogger. Just add those to the bottom there. I don't know if he wants to put them in alphabetical or anything. It doesn't look like. Oh, A, I, P. He does appear to be putting things in alphabetical. If G, H, J, L. So I'll just keep it alphabeticalized. And then let's try and do some simple messaging. Let's try info test. So cargo build. Let's see if that works. Oh, could not compile. Info test use of unstable library feature. Use the crates.io log library instead. I am trying to use the log library. What are you talking about? Library feature Rust private. Use the crates.io log library. I am. I'm trying. Was there something I missed? Oh, I think I might have to add use log GHJKL. Okay. Let's try that. And then nvlogger init unwrap. I put that in. Was there anything else? And what are the macros of Rust log? Just trace extern crate log. So here are the macros: debug, error, info log, trace logs message at the trace level. Okay. Anyway, let's see if this builds now. Do you like it now that I've said use the log level something or other? Nope, still doesn't like it. Could not compile. Extern crate log. Maybe I should read this feature, or read this issue. Rust, lang, issues. Rust, issues. What's happening here? If you mistakenly do this but don't require log in your cargo, you may trigger this bug. This fix is add to log 0.3 to your cargo.toml. So I wonder if that's the problem. I have to add which log is being used. And log. It's using log 0.3.6. So wait, hold on. June 2016. If I were to like whoop. So like if I do this, is that? I'm just guessing here. Just guessing. Ooh. Hey, alright, that worked. So weird. The more up-to-date version of log, I guess, doesn't work. So this is helpful. I'm going to add a thumbs up. I don't know why that happened. We need the stability attributes. Should compile unstable Rust. Log. Alright, well, anyways, we need to depend on okay, so now that we've built, let's try and run our compilation. What do we build? Under target, there should be something called Ipdl Parser, and I'm going to run it. It panicked. Thread main panicked. But if I run... Now, what did I put in there? I put in a log message that was like test, and it was an info. So if I do a log level of info, rust underscore log equals info, and then run it. Then I get test. Hey, that works. Okay, good. Okay, so we've got that working. That's nice. But I'm not sure if we need this in here, to be completely honest, because I think what we might want to do here is panic instead. So like match maybe TUS in the event that it's okay. Let TUS equals match maybe okay. M. Otherwise, r sum. It's none. Maybe we should panic. Specification could not be parsed. Let's see if that builds. No, it doesn't like it. Print expected one of, oh, I'm missing a semicolon, I think. Wait, am I? It's a match required. It does, okay, yeah. Okay, so now if I run that, well, I never got here because I didn't get here. So I'm going to pass some things. What's a good thing to pass? So it wants at least one Ipdl file specified. So I'm going to pass it. I think there's one under dom ipc p browser.ipdl. Parsing it cannot locate include file, and then it panicked. So it attempts to parse it. So I'm actually going to remove the logging from in here. Put the logging elsewhere. I'm going to get rid of that, and that, and that. We're going to put it inside parser.rs. And what was the other stuff? Excuse me, and then we initialize it. What's the initialization? Log levels are controlled. Initializes the global logger with an env logger. So if we're inside a module that doesn't have a main, where would it be a good place to put that? Let's see what GitHub thinks. There might be other people who have done stuff like this. Some code, Rust. Init logging in main, say hello, main. They're putting inside main. I'm looking for something that's not a main. Maybe main is the right place to put it. Shoot. Init logging. Alright, I was wrong. Okay, so, whoops, back we go. That's what you get. Now, we don't need log level because we don't actually do any logging in here. But we can re-add those, and then I'm going to put this inside here. And then I'm going to actually, you know what I should do before I do all this? Let me not get ahead of myself here, but we should probably commit some of these changes that we made so they're not all like jumbled up. Okay, so if we look inside the changes that we've made, I've added endvlogger, cargo.lock, and then this is the stuff I think I want to commit right now. And then this stuff inside Parser I don't want to commit. So I'm thinking I want to commit just this right now. So we'll do that. Refactor how we mildly refactor. Use a matcher for returned translation units. Translation unit option. Use a match for return. Okay. And then I'm going to add the log. I'm going to sort of shelve this, or git stash. Can I stash like a particular file? Stash changes in dirty working directory away. Man, I can't stash a particular file. All right. So then I'm just gonna undo the changes to here. And so we're adding to cargo lock. We're adding log. Git add. All right. Cargo.lock. Git add cargo.toml. Git commit. Logger. Add endvlogger and log modules to cargo. Toml. Okay. So no other changes that are waiting. And then inside main.rs, I'm going to put back the initialization of the logging. And hopefully that still builds. Let's try that. Yeah, okay. Git status, git diff. We should just be adding those things. Except we don't need the macros, so how will that build? I say we don't need the macros because nothing in there has logged yet. Okay. Git add source main.rs, git commit, initialize global logger in main.rs, and then we're gonna add some logging inside parser.rs. I think we just need these. So we probably don't want to output this. So that's kind of what we're doing here. Info, parsing file. And if there's an error, I think it's just error. Can't locate include file. Or else are we print lining? Alright, include context. Let's say it's info. Oh, that's part of the error, I guess. It's being used as part of the error message. Interesting. Alright, well, that's a bit weird, but let's just move on. Then here, cannot do something or other. Okay, and then there's a typo here. We're gonna, whoops, we're gonna fix that. So let's try and build that. Whoops, daisy. It's never heard of these things. Loading macros must be at the crate root. Okay. Whoopsie daisy. So I guess we have to do that over here. We do have to do that here. Cargo build. Macro undefined. What? So I have to do it in both places? Loading macros must be at the crate root. Let's quickly search for this problem. First the outer scope, when the next time here is unnecessary. How do you import macros and submodules? That's exactly what we want. Do like Kapar told you, an extern crate loading macros must be at the crate root. It's put in the crate root, which is made. You can then just use the macro in your submodule. Macro. Extern crate. But that's not what's happening. Oh, maybe because we need to put these inside main. Is that right? No, it doesn't like it. Macro undefined. Info. You sure? Do I have to like extern crate use? What? I don't get it. Macro undefined info. Cargo build work. We commit with both nightly and Why can I not get the log macros in here? Do I have to like use them? Do I have to say that I'm using log? I think I tried that before. Let's take a look at what we've got. In main, we're saying, yeah, we've got an external crate log and we're using the macros there. We put it in main.rs, log level, and we changed all of those things. I wonder if I have to cargo clean. Let's start from scratch. Cargo build. Cargo build. Maybe it didn't realize. So I'm just clobbering and building again. Compiling nvlogger. Compiles that. Lollerpop. I got a bad feeling about this. I might not be able to get this compiled. Come on, come on, come on, come on, come on, come on. What are you waiting for? Oh my goodness, that is a slow build. Whoops. Now compiling Lallerpop. In the meantime, is there something else we could do with our time that's useful? Let's see. What else do I have on the agenda? I think it's too late. It's too late to context switch. We've only got, like, I want to get this thing built and working, and then I'm going to end the episode. I'd really like to end it on that note, as opposed to a different note of it not working. Why is this build taking so long? Holy smokes. Okay, now it's compiling Ipdl Parser, and it doesn't like it still. So a clean build is not... It just could not compile Ipdl Parser because it's never heard of these undefined macros. Macro undefined. Oh no. Oh no, I think I'm dropping a bunch of frames. I'm guessing that the network is screwing on me. Is everything okay? I saw a bunch of frames get dropped. Am I still on the internet? Oh boy. Am I still on the internet? Yes, I'm still on the internet. Good. A bunch of frames got dropped there. I'm dropping frames like crazy. Alright, well, I've stopped dropping frames. Stop, drop, and roll. But you know what? I'm worried about this stream. Maybe something's up with my network connection right now. Oh. Okay. I'm going to end this on a mystery. I'm going to end this stream right now. I'm sorry if you're watching the live stream and like I'm dropping frames like crazy. I unfortunately cannot get this thing to compile. I don't know why. And when I eventually find out, I'm going to post a pull request up on GitHub. If you're interested in following along and maybe looking at what I ended up writing, I'm going to eventually attach it or associate it with this particular issue that I hooked up in GitHub. So I guess follow along with that. Hey, thanks for watching episode 85 of The Joy of Coding. Sorry I couldn't end it on a more positive note with this thing building properly. I'm just going to bail now while my network appears to be working okay. I want to call out something. This was episode 85, and I spent part of the holiday taking some time to think about how I can improve the stream. So I was watching some other streams, and I stumbled upon a really good one that I want to share, and I'm going to put it under my my links here. So there's this fellow who I think his name's Casey. I've been watching this thing called Homemade Hero, which is a fellow who's like, or Handmade Hero. This fellow is constructing a game for Windows from the ground up. He's not using any of the sort of like big engines like Unity or Unreal or anything like that. He's building a little game for Windows from scratch like they used to do back in the day, and he's doing it just like hour by hour, and he's live streaming it, and it's really, really good stuff. He's great at explaining stuff. I've been enjoying it. Check this out. It's called Handmade Hero. Watch a developer put together a Windows game from scratch, no third-party engines. Really great explanations. And he's still working on it. He does it like just an hour at a time. There are like hundreds of episodes now. And I do suggest you check it out. It's really cool. So Handmade Hero, big thumbs up there. I'm really enjoying that. But you can also let me know what you think of the episode and how I can improve things in the new year in 2017. One of the things I'm hoping to do this year is multicast stream across AirMozilla, Twitch and YouTube Live. Hopefully I'll have that set up for next week or maybe the week after. Maybe then I'll be able to expose the joy of coding to more people. But let me know if there's other stuff I can do. There's a form you can fill out. There's a link to it here in the agenda. There's another one in the additional links section below, or there's one in the, if you're watching this on YouTube, the description section of the video. And let me know what I can do to improve the stream for you. If there's stuff that you'd like me to try and look at, or if there are particular things that you prefer over other things. Would you like to see more Rust? Would you like to see less Rust? I spent a lot of time explaining the Rust code, kind of talking it through while I was figuring it out in my head myself, and I spent maybe only 20 minutes writing some Rust. What do you think? Do let me know and fill in this form, because I want to know that stuff. I want to thank you for watching episode 85, The Joy of Coding, and for joining me for the first episode of 2017. I hope you enjoyed it. I hope it was useful, and I will see you next week with episode 86. Until then, take care. Wait, hold on. I gotta switch to my splash screen. Take care. Bye-bye. What? And the sounds took that opportunity to stop working, probably because my network dropped. Oh, come on. Reload. Just give me a second.
The joy of coding.
See you next week.